Welcome to Lesson 10.1, Part 1, EWM Integration, Architecture and Key Concepts, from the course SAP S/4HANA Cloud Supply Chain CS4CSC by KRTI Edu. In this lesson, we'll discover how Extended Warehouse Management, or EWM, forms the operational heart of the S/4HANA Cloud supply chain architecture and how it integrates seamlessly with inventory management. EWM controls every physical movement in a warehouse: receipts, putaway, picking, staging, and dispatch. In S/4HANA Cloud, it's embedded within the same digital core as inventory management, eliminating data duplication. We'll look at the overall structure, the document flow between systems, and the technical backbone that keeps data synchronized in real time. By the end of this session, you'll be able to explain EWM's role in the cloud supply chain landscape, describe its architecture, follow its integration document flow, identify key master data objects, and map the relevant Fiori apps that you'll see both in projects and in the certification exam. Role of EWM in the supply chain: EWM extends beyond simple goods movement postings. It manages the physical layout of the warehouse, labor resources, handling units, and complex activities like wave picking. For planners and supervisors, it provides real-time visibility of every bin, pallet, and carton, enabling precision control and reduced dwell time. Embedded versus decentralized EWM. In the cloud world, we distinguish between embedded and decentralized EWM. Embedded EWM runs within S/4HANA Cloud itself, suited to small and mid-size warehouses where simplicity and speed are priorities. Decentralized EWM runs on a separate instance connected through Integration Suite, reserved for very large or high-volume operations. Public edition customers always use the embedded version, ensuring tight coupling and zero interface lag. System Architecture Overview. Within S/4HANA Cloud, EWM communicates with the inventory management layer through internal APIs and message queues. When a delivery is created, a warehouse request is generated automatically. Task confirmations in EWM trigger stock updates back in IM, all in real time. This architecture replaces the legacy IDOC-based interface, giving you instant data consistency. Integration document flow. Here's the standard flow. An inbound or outbound delivery in IM creates a warehouse request in EWM, which spawns tasks for putaway or picking. Once confirmed, the goods movement posts in IM. Each step updates quantities, valuations, and statuses simultaneously, ensuring the physical world and the system stay perfectly aligned. Technical Communication Framework. Traditional middleware such as CIF and IDOC interfaces is no longer needed. Instead, asynchronous QRFC queues and modern OData APIs provide the transport layer. This lightweight framework increases performance, simplifies monitoring, and guarantees reliable message delivery between the logistics layers. Key integration objects. The integration revolves around core data objects, delivery documents that bridge IM and EWM, handling units for packaging, warehouse tasks and orders for execution, and the quant that defines stock at bin level. Each of these is automatically synchronized through the EWM APIs when you execute a transaction. Organizational structure mapping. Every warehouse has a hierarchy. Warehouse number at the top, then storage types, sections, and bins, plus work centers for activities like packing. Each warehouse is linked to a specific plant and storage location in S4. Understanding this mapping is essential because it determines where postings appear in finance and how physical space connects to accounting values. Master data synchronization. EWM uses the same product, batch, and unit of measure data as the rest of S4. When you activate configuration, that data is replicated automatically to the EWM layer. Business partners, customers, vendors, carriers are also shared, enabling consistent identification across procurement, sales, and logistics. Process integration example. Inbound flow. Imagine a purchase order arrives. An inbound delivery is created in S4 and transferred instantly to EWM. EWM raises a warehouse request and generates putaway tasks. When goods are confirmed at the bin, the system posts the goods receipt in IM. Your stock levels update immediately across both layers. No manual reconciliation needed. Process integration example. Inbound flow. Imagine a purchase order arrives. An inbound delivery is created in S4 and transferred instantly to EWM. EWM raises a warehouse request and generates putaway tasks. When goods are confirmed at the bin, the system posts the goods receipt in IM. Your stock levels update immediately across both layers. No manual reconciliation needed. Exception handling and monitoring. Errors can still occur, perhaps a missing delivery reference or a stuck queue. Supervisors monitor these in the Warehouse Monitor F2755 or the Application Interface dashboard. Automatic reprocessing recovers temporary failures, and exception codes let users manage block bins or damaged stock quickly and transparently. Key Fiori apps for EWM integration. Core apps you must know. Monitor inbound deliveries F2759, Warehouse Monitor F2755, Pack Handling Units F2757, Monitor outbound deliveries F2758, and Physical Inventory in EWM F2762. These provide full visibility of delivery, task, and bin activities, important for both daily operations and exam questions. Embedded analytics for EWM. EWM contributes KPIs to the Inventory Management Overview F2991 dashboard. Supervisors can monitor open tasks, bin utilization, and delayed putaway in real time. Smart business tiles turn operational data into insights, allowing rapid corrective action inside the same system. No external BI tool required. Integration benefits. The payoff is clear. Accurate stock positions, a single source of truth across IM and EWM, faster logistics cycles, and simplified system architecture. You gain end-to-end traceability that connects warehouse operations directly to finance and transportation planning, delivering measurable ROI. Certification focus points. Expect exam questions on the differences between embedded and decentralized EWM, the standard document flow, and the roles of delivery documents, handling units, and warehouse tasks. Be familiar with QRFC concepts, API communication, and the main Fiori apps. These appear repeatedly in the CS4SC certification blueprint. To recap, EWM is the advanced execution layer inside S/4HANA Cloud that manages warehouse tasks, handling units, and stock accuracy through real-time integration with inventory management. Next, we'll continue with Lesson 10.1 Part 2, Configuration and Process Mapping, where you'll see how these architectural concepts translate into actual system configuration and flows. This is KRTI Edu. Learn, practice, certify, succeed.